Hello everyone, welcome to AI in Healthcare video course. Thanks for watching. Today episode is dedicated to different types of AI and machine learning models for analyzing healthcare data. In past months, when I was talking to different nurses and doctors, I understood that in most of the cases when I say AI, it's immediately associated with ChatGPT, with large language models, but it's only a part of what AI can do for healthcare, and I decided to record this video to show other opportunities how AI and machine learning can help in processing of healthcare data and providing some kind of decision support. So let's assume we have 68-year-old patient after surgery. It requires some additional oxygen, and there are some inflammatory markers. So what we already have in any intensive care, in any hospital, we have a rule-based warning system. So assume that, like, based on retrospective data, based on experience of medical doctor or some guidelines that also developed based on retrospective data, we have rules that if SpO2 drops below 90% or respiratory rate rises above 30 per minute, so we trigger alarm threshold. If it's something in between, then we trigger alarm, another type of alarm, less urgent, but still we need to monitor closely this patient. And it works obviously, I think, in every hospital in the world. The only difference, these thresholds can be a little bit different, depending on equipment, depending on guidance, and they obviously help. There are a couple of issues with this rule-based warning system. So first of all, based on, again, multiple studies, 60 to 80% of all alarms in intensive care, for example, are false. So it leads often to alarm fatigue, and what we saw a lot of times, this threshold are set like too high. For example, trigger alarm only when patient has like SpO2 below like 85, for example, or heart rate like 140. So only at this moment trigger alarm. Usually we understand it's actually too late, and like it can lead to some excessive length of stay, prolonged length of stay, or deterioration. So it's something that we want to avoid usually. The second problem with this rule is that, like, for example, these conditions currently, they will be considered as everything is okay, but likely it is not. So, for example, now we'll need to make it a little bit better. Yeah, so this patient is considered as fine, and we just increase heart rate a little bit, and then it's, but maybe it's already, and so this difference for different patients, for example, considering their age, can be very different, and it's difficult to take into account in our protocol and rule-based system all the possible conditions, and personalize this rule-based system for each patient. So that's the profit and benefit, that it's simple and it works. Some trade-off is it's not personalized, so it doesn't work stable for any patient. And that's where classical machine learning can help. So basically, most of the classical machine learning tools, it's also some kind of rule-based decision support. So we talked previously in previous episode that machine learning model is model that multiplies features. For example, in our case, it can be age, SpO2, heart rate, inflammation markers, to some numbers. They called weights. And these weights appear from retrospective data. So a model during training, it feed these weights in a way that the model will make less errors on retrospective data. So model saw 1000 patients. Some of them were, for example, deteriorated in 6 hours, some of them not. And based on this information, it created these weights, these coefficients to these features in a way that model will be more often right than wrong on retrospective data. I hope it's a little bit more clear now. If not, let's see further. So here is information about retrospective. So this is previous cases. And so we see that patient with these parameters was not deteriorated in 6 hours. So for model, this patient is stable. This patient is considered unstable because model knows that based on data from somewhere, but it's for sure because we know it was already happened. Patient deteriorated and it's highlighted as red. And based on this information, model have to draw a line that will separate patient who deteriorated and not as more accurately. And when new patient appears, so this line is basically this that defined by this formula, by this coefficient. So it defines where it will be drawn, and angle of this line will separate patients unstable and stable. And when new patient appears, it placed on this chart, and depending on how far from this line, a model can say the risk of deterioration. In this case, it's 71%. And then our goal to evaluate, like, is it good or not? So is it enough for us to make additional measures or not? Currently, model separated everybody with higher than 50% risk will deteriorate, and lower, then they will be stable. But important to notice that machine learning model never says will patient deteriorate or not. It always provides some probability of the event, like 71%. And our goal is to make this interpretation. And again, we can do this. We will talk about this in next episode, but some spoiler that we do it also based on our experience and current needs specific of the disease. What we afraid more, to make more unnecessary additional diagnosis, or to let patient deteriorate before we make intervention. So that's again trade-off how we will interpret this 75% number. One of the benefit of machine learning comparing to rule-based logic is that it takes into account more parameters. So for example, the same patient here, like if its patient is 50, it's like considered as stable. If it's 75, it's already more risky. So it's a little bit more interesting than just simple rule-based logic, because for some patient it can be like it can be okay, like SpO2 93, if previously patient with these parameters didn't deteriorate, for example. At the same time, if it's inflammation markers higher, so even with good SpO2 and lower heart rate, patient will be considered as quite at high risk. So it takes into account more parameters and potentially can reduce alarm fatigue and may make decision support more precise, more personalized. that's the reason why machine learning can be helpful in as a decision support system for intensive care or in general healthcare. But again, the benefit of machine learning is that this is 100% deterministic, so it doesn't matter how many hundreds of times we will evaluate this specific patient. It risk always will be 52%. So that provides some consistency with the results. So it's difficult to hallucinate. It's difficult to invent something that do not exist, because it's the same as rule-based formula. So basically this is rule-based formula. The only reason coefficients are taken and weights are taken from previous experience. And that's the difference with rule-based, and that's why it's called machine learning. Another episode, another part of AI in healthcare is computer vision. So it's actually similar to what we talk now about machine learning, but if before model was trained on some numerical data like heart rate, SpO2, and it knew about future of this patient because it's on retrospective data. Computer vision models are trained on thousands or even millions of, for example, X-ray scans or MRI, computer tomography, like something. And it learned also on labeled X-ray examples, X-ray scans. And it knows that if there is something at this part of the, for example, lungs, and it was previously highlighted as clinicians on labeled dataset as something that require attention, so AI model will highlight it also as something that require attention, like with, for example, in this case, quite high probability that it requires something. Important to say that none of computer vision models know about that this is lungs, that this is cancer potentially or something else. So it knows only brightness of pixels. So it analyzes patterns on the image and only analyzes where this brighter pixel is placed, where other bright or dark pixels are placed, and it evaluates purely on pattern and brightness of the pixel. So it doesn't know physiology, but it's still helpful. So here, for example, a real example from some study. So here was first scan, and model highlighted that at this place there is something that requires attention. And here is scan after 3 years, and we see that it was confirmed, this pathology was confirmed as lung cancer. So AI model highlighted something like very subtle nodular opacity in the lungs quite early. So even that model doesn't know what cancer is, what lung is, it knows very well millions of X-ray scans, and it knows that in, for example, hundreds of thousands of other X-ray scans with the similar patterns, later it was cancer, so it highlights, and with a usually quite high, we will talk about it later, probability, like accuracy, it's indeed might be cancer. So about metrics, how we evaluate, we talked about this earlier, but we will talk about this again later in one of the next episodes, because it's really important topic. But that's how machine learning, computer vision system work. That's actually also machine learning. It's usually developed with deep neural networks, computer vision systems, but idea is almost the same. The difference is with what we talked before. Weight is given to each specific pixel, and it provides also some score or some result that says, do we need attention to this specific X-ray, or it's similar to which were previously considered as normal and safe, stable. And finally, indeed, large language models, they exist, they work, they help, and that's how can they help. So here is, for example, some raw text, some briefly note, clinical note, and LLM can make some summary, and even it can provide, based on which parts of the note it build this summary. It can draft structured problem list, for example, and based on our instruction, we can get different summarization or different style of summarization. We can get some patient-friendly description without specific terms for family or for patient, so to provide more transparency and explainability. So it's indeed a helpful tool, but it's not only what exists in AI. Interesting thing that there is an opportunity to test, like, does this specific model hallucinate or not? So we can ask something that model cannot know from existing data, and the right answer should be like, I don't know. So that's important question that's now really it's now widely discussed, to teach models not to answer question that it doesn't know answer. So to answer I don't know, this is not as easy as we hope, but still it's possible. So in this case our model passed this result. So that's how LLM can help. Usually it's some administrative tasks for like summarization, communication with family or patients. So it helps a lot with administrative tasks. With clinical decision support, with the healthcare AI and healthcare itself, actually there is more focus now on like computer vision and machine learning system. But very likely large language model also will evolve to something that like some kind of agentic AI in future that will take into account, for example, information from classical machine learning models, like, for example, weights this risk. It will take into account results of computer vision models. It will take into account results of previous history, and will suggest additional analysis, for example, and or help with diagnosis even. So this is technically possible. Very likely it will take some time, but it's something that we can expect in future. So some kind of agentic AI that will in hospital will take into account different multimodals sources of data, computer like images, maybe ultrasound. It will be processed with specialized AI models. It will take into account models that work with time series data. It's another type of AI that we will not discuss now. It takes into account some data from HR, also processed with another type of AI, and provides some summary, explainable, with references why it happens, and we hope it will really reduce clinical burden and reduce alarm fatigue and improve care. So collaborating with human experts, and how it happens we will discuss in further videos. Please follow us, subscribe, ask questions, share to your colleagues, and I really appreciate your feedback to make this video course more useful and helpful. Thank you for your attention. See you next time.